A bond that holds two or more atoms together. Chemical bond. A chemical bond is a connection between atoms, allowing them to form compounds.
Imagine trying to keep a group of friends together at a crowded concert. Just as you might hold hands or link arms to stay connected in the bustling crowd, atoms form bonds to stay together and create molecules. In both situations, a bond acts like the link or connection that prevents separation. For people, it's the physical grasp, and for atoms, it's the chemical bond that holds them together in the vast crowd of the universe.
A shorthand that uses symbols to represent elements in a compound. Chemical formula. A chemical formula shows the types and numbers of atoms present in a molecule.
Imagine trying to explain a complex recipe to a friend, but you only have a few seconds to do so. This is similar to how scientists use chemical formulas to convey detailed information about compounds quickly and efficiently. Just as the recipe shorthand might list 2 eggs, 1 cup sugar, 1 cup flour to summarize the ingredients, a chemical formula like H2O uses symbols and numbers to represent the elements and their quantities in a compound, allowing for quick understanding and communication.
The substance made when atoms from two or more elements combine chemically. Compound. A compound is a substance formed when different types of atoms bond together, like water being made of hydrogen and oxygen.
Imagine trying to bake a cake using flour, sugar, eggs, and butter. Each ingredient is essential, but none can make a cake on its own. Similarly, a compound is like that cake, created when atoms from two or more elements come together in a precise way to form a new substance with unique properties. Just as combining ingredients produces a cake with characteristics different from each individual component. Combining elements chemically results in a compound with properties distinct from the atoms that compose it.
A chemical bond formed when atoms share electrons. Covalent bond. A covalent bond is when two atoms stick together by sharing some of their outer electrons.
Imagine two friends who each want to watch a movie, but neither can afford the streaming service on their own. Just like these friends decide to share the cost of the service to both enjoy the movie, atoms in a covalent bond share electrons to achieve stability. In this analogy, the streaming service represents the shared electrons, the friends are the atoms, and the act of sharing ensures that both parties, or atoms, get what they need, which is stability in their respective situations.
The attraction between oppositely charged ions. Ionic bond. An ionic bond is a strong connection formed when one atom donates an electron to another atom, resulting in positively and negatively charged ions that stick together.
Imagine you're trying to get two different types of people to sit together at a dinner party. One who loves to chat, and the other who prefers to listen. This situation is similar to an ionic bond, where oppositely charged ions are drawn to each other because they complement each other's needs. Just as the chatty person, like the positively charged ion, and the listener, like the negatively charged ion, naturally pair up to balance the conversation. Positive and negative ions attract each other to form a stable ionic compound.
A bond formed when metal atoms share electrons. Metallic bond. A metallic bond is when metal atoms pool their electrons, allowing them to move freely and create a strong, flexible connection.
Imagine you're at a crowded concert where everyone is trying to pass around a limited number of glow sticks to keep the party going. Just like the concert-goers sharing glow sticks to stay lively, metal atoms share electrons to maintain a stable structure. In this analogy, the concert-goers are the metal atoms, the glow sticks are the electrons, and the lively atmosphere represents the strong, cohesive force of a metallic bond that holds everything together.
The unequal sharing of electrons in a covalent bond, polar bond. A polar bond is a type of covalent bond where electrons are shared unequally, causing one end to be slightly positive and the other slightly negative.
Imagine you're sharing a blanket with someone on a cold night, but your partner keeps hogging most of it. This uneven distribution of the blanket is similar to the unequal sharing of electrons in a polar covalent bond. Just like one person ends up with more of the blanket, in a polar bond, one atom attracts the shared electrons more strongly, creating a partial negative charge, while the other atom becomes partially positive, much like the chilly person left with less blanket.
A solid of ions or atoms arranged in an orderly three-dimensional pattern. Crystal. A crystal is a structure where particles are arranged in a repeating, organized pattern.
Imagine trying to organize a bookshelf where every book has a specific spot, and you can't just place them randomly. This is similar to how atoms or ions are arranged in a crystal, where each particle has a precise position in a three-dimensional pattern. Just as a well-organized bookshelf allows you to find and access each book easily, the orderly arrangement of particles in a crystal ensures structural stability and predictability in its properties.
An ion made of more than one atom, it may have a positive or negative charge. Polyatomic ion. A polyatomic ion is a group of bonded atoms that together have an overall electric charge.
Imagine trying to carry a stack of groceries with various items balanced precariously in your arms. Just like these groceries, which are a collection of different items that you must manage together. A polyatomic ion is a group of different atoms bonded together, carrying a collective charge. Just as the groceries might feel heavier or lighter depending on what's in the stack, a polyatomic ion may have a positive or negative charge depending on the balance of electrons among the atoms, all moving as a single unit.
An electron in the outermost energy level of an atom, it helps form chemical bonds. Valence electron. Valence electrons are the outermost electrons of an atom that determine how it reacts with other elements.
Imagine you're at a party and you're the person standing near the door, ready to meet new people and make connections. Just like you're positioned to easily interact and form new friendships, valence electrons are positioned in the outermost energy level of an atom, ready to form chemical bonds. In this analogy, you are the valence electron, the party is the atom, and the new people you meet are the atoms or molecules that bond with you, showing how valence electrons are crucial for forming bonds, much like you are crucial for forming social connections at the party.
A number written below and to the right of a chemical symbol. Subscript. In science, a subscript indicates the number of atoms of an element in a molecule.
Imagine you're trying to bake cookies and need to know how many cups of sugar to use for each batch. Just as the recipe tells you the exact amount of sugar needed for each set of cookies, a subscript in a chemical formula indicates the number of atoms of an element in a molecule. In both cases, the number is crucial. The recipe's measurement ensures the right sweetness, while the subscript ensures the correct composition of the molecule.
A model that represents an atom's outside electrons using dots. Electron dot diagram. It is a simple diagram that shows the valence electrons of an atom as dots around the element's symbol.
Imagine trying to remember which of your friends are available to hang out by looking at a calendar with dots on it. Just like how each dot on the calendar represents a friend who is free on a particular day, an electron dot diagram uses dots to represent the electrons available for bonding in the outer shell of an atom. In this analogy, the calendar is like the atom, and the dots signify the friends or electrons that can interact, helping you visualize which atoms can bond together, much like figuring out whose schedules align for a gathering.